Biosecurity space now. So I'd like to welcome to the stage Gustavo Rosso, who's going to talk to us about bird flu. Please give him a round of applause.
Good afternoon, everybody. Hope you're all having a great time. My name is Gustavo, I work for MPI, and my presentation will be about bird flu preparedness, surveillance, and monitoring. So I'm a senior geospatial analyst in the geospatial team that sits under the corporate services unit at MPI. So this team is managed by Helen Simpson. And we have Megan, Sam, Fraser, Josh, and Julianne as absolute superstars, and me. And this is what we do. We manage to support the GIS platform across the ministry and provide geospatial tools. So basically, we create dynamic maps, dashboards, field apps, etc. We're also responsible for the geospatial data management for enterprise data. So we set data, metadata, and open data standards, and we ensure that these standards are met. We work with the advisory team to translate business needs into solutions, and we provide GIS support across the organization through training and user awareness of the tools and processes. All right, so a bit of a background of the bird flu, or high pathogenicity avian influenza, or HPAI. There are outbreaks going on around the globe. Recently, the H5N1 virus strain has been detected in Antarctica. There is a risk of occurring in New Zealand through infected migratory birds, or infected people, or contaminated material. Obviously, it's a threat to New Zealand's bird life, and if HPI is detected, Biosecurity New Zealand is the lead agency and will coordinate a response, and any actions such as vaccination or depopulation will depend on the species and its location. So how we got involved. Geospatial team was approached by diagnostic surveillance team in Biosecurity New Zealand to develop a field collection tool for ongoing HPI surveillance and monitoring. So as part of the surveillance, samples will be collected, and these collected samples will be tested at the animal health lab, and their data will be managed in LIMS, which is the Laboratory Information Management System. So I talked about location, surveillance, monitoring, field data collection. So I think we all know what's coming now. This Survey 123 to the rescue. So now with Survey 123 in play, we have to design the survey form. The requester supplied the data schema, which was developed by animal health surveillance SMEs, and it covers 3 different scenarios: commercial birds, backyard birds, and wildlife birds. Commercial birds is when the event location is in a property that is linked to agribase. That means it has an agribase ID. Backyard birds is when the event location is in a property that doesn't have an agribase ID. And wildlife birds is when the event location is not in a property. For the commercial birds, which is believed to be the vast majority of cases, it will pull data from agribase. And for the whole form, for the whole survey, we have 4 levels of nested data. So in a one-to-many relationship. So property, flock, birds, and sample if it's commercial or backyard scenario, and location, event, bird, sample if it's wildlife. So there might be multiple samples for one bird, multiple birds for one flock or event, and multiple flocks or events per property or location. Okay, so this is how it looks like in Connect. I'm not sure if you guys can see that. So the first thing that the user we need to define is the type of sampling event. So let's go one by one now. So when the user selects commercial birds, they will have these, the agribase ID field in there. So they're gonna type the agribase ID. This information will be known beforehand. And all those fields down to ostrich number will be automatically populated. The rest will have to be entered manually. If it's a backyard scenario, now it doesn't have the agribase ID field anymore because that's the definition of the backyard. It's a property not in agribase. Instead, you have farm type that defaults to backyard, but you have other options like poultry farm or lifestyle block. Now it has an address field with a geocode appearance, so you just start typing the address and the field gives you a few options based on what you have typed so far. And similar fields to the commercial ones, but you have to enter manually. And for wildlife, there's no farm type. You see that the text changes to location now because it's not a property. So just a location type. And an address is not mandatory now because it might not have an address. And just another 3 fields. Okay, so the output data would be a host feature layer, a web mapping application, ArcGIS online groups to group, only one, to accommodate the items, and LIMS will be able to access the submitted data through a REST service using the unique ID to track back to the first level. So they will access at the lowest level, which is a sample in this case, and they'll have this unique ID track back to the first level. And the unique ID will be automatically generated depending on the type of sampling data. So this is kind of what the output data looks like. Again, I'm not sure if it's visible. It should be all right. The tests and the lab fields you're seeing there, they're hidden from the form, but they're still accessible to LIMS, again, through the REST service. And you see the unique ID in there. So if it's an agribase, if it's a commercial scenario, the unique ID will concatenate the agribase ID plus the flock number, bud number, and sample number. And if it's a backyard scenario, you have the initials of the users, and then concatenate with flock number, bud number, and sample. Cool, so limitations. At the beginning of the project, the requester wanted to have some sort of mass collection functionality. So for example, let's say that there are 100 birds from the same flock, from the same property, they all have the same age, they're the same species, they have the same symptoms. Would be interesting to be able to collect them all at once without having to do one by one. That sort of worked with a little JavaScript that would allow the user to, first, with an extra field that would determine the repeat count, and then a little JavaScript on the background that would allow the user to manually enter only the first attribute and then copy everything across. But then there could be the case of having out of these 100 birds, for example, only one of them could have a different symptom. And then you can't just go to the last one and change only that little guy, because that sort of, to try that, I tested quite a few times, that sort of broke the JavaScript, so that didn't really work. So we thought about having an extra field at the beginning of the form that would define if the collection method would be a mass collection or individual. So in this case, if the individual method would be selected, then the form would go back to the original setting, one by one. And if it was the mass collection, then the JavaScript thing would kick in. That still didn't address the problem. The user would still have to go through every record to commit the data, because the number in the repeat count only sets the number of entries. It doesn't really commit the data, so they still need to, we have to click through all of them. Plus, apparently Connect doesn't like the combo of JavaScript on the background and a field having a minimal or compact appearance. So for example, we have one field that is symptoms. It's a list with maybe like 20 options or so, and you can select multiple ones, all that apply. And in this configuration, you have the drop-down menu. When you click to expand, you would select, I don't know, 2 or 3 of them, but as soon as you select the first one, the menu kind of collapses back again. It doesn't allow you to do anything else, and the data doesn't commit. So it was getting annoying, was getting more and more complex, time was running out, and we all agreed to compromise with this functionality, unfortunately, and we just went back to the default settings of Survey 123 Connect, and a few staff would just have to collect one by one. So my take on this little piece of work was the collaboration across the organization. We had different teams involved, like surveillance incursion, lab system, surveillance data system, with different people from different backgrounds. We had initial communication to understand the requirements, possibilities, and limitations. We had constant catch-ups to track progress, identify issues early, testing over and over again, different devices, laptops, mobiles. I had loads of consultations with others from my team. And at the end, we just everyone coming together to deliver a product that, at the same time, that fits the business needs, helps Biosecurity New Zealand having a response ready towards threatening disease. And that's pretty much it. If you want to know more about the geospatial component of this little piece of work, you can email GS Hub, which is the geospatial team inbox, or you can just check the MPI website on the biosecurity to know more about HPAI. Thank you.
Awesome, thank you, Gustavo, and appreciate your mahi keeping our wonderful wildlife of New Zealand safe. So.